Hi, David from Electric Teaching here, and I'd like to show you how to do quadratic algebra and what does that mean versus regular algebra. And I think that's really important when you get to this stage of high school math or maybe 8th grade math, that you recognize the difference here. So let's just dive into some problems here, and then I'll explain what all my words and instructions are. I think this will be helpful in the big picture, but please excuse how I've cluttered up the screen. It says solve for x in this one. And if we're in regular pre-algebra, early algebra, we normally undo the actions on the variable x, trying to get it isolated. For instance, I see it's 2 times x squared plus 2. So I'm thinking I can undo those actions and get x by itself. And this is why I want you to, when seeing a quadratic equation, that's one with the most powerful term being a quadratic term. There's a constant and a quadratic and another constant. There's 3 terms in this one. And so when you look at this, you're looking to see if there's a linear term. Okay, if there is a quadratic term and no linear term, as I'm trying to state over here, if there is a quadratic term and no linear term, then just perform normal undoing action algebra to isolate the variable. So what I mean by undoing actions, I can see that there are 3 actions upon x here. It's being squared. That would be the first thing I'd do in order of operations. Then it's being multiplied by 2, and then it's being added by 2. So you want to work that backwards. You're going to want to subtract 2, divide by 2, usually in fraction form, not division form here. And then you want to take plus or minus the square root. These are the 3 actions that will get x isolated and by itself. If there were other terms out here that was an x squared term, I'd collect them first. So let's try that. Let's subtract. So if I subtract 2 on both sides, I'm going to get 32 on the left-hand side, a 2x squared on the right-hand side. If I divide by 2, I'm going to show that this way. Divide by 2. Okay, and that 2 over 2 makes a 1, and so using the identity theorem in a sense, or the 2's just simply cancel because it's a removable 1, you're going to be left with x squared now by itself. It doesn't bother me that x squared's on the right side here. It doesn't bother me that it's on the right side. I'm just going to move something out of the way here and make it a little bit easier for me to manage here. Take this and move it down just a little bit here. Say, in fact, we'll set it right over here. Now, over here I'm dividing by 2 again, dividing by 2, so what's that? 16. Last step is always plus or minus the square root. I'm encouraging my students to not just say take the square root of both sides. If they say that, they will constantly forget the negative option there. So when you're doing algebra or the undoing actions here, you want to think plus or minus the square root on both sides. I'm going to put plus or minus on one side, and that'll suffice for both conditions then. I'm going to bring x over here on the right side to present my answer, on the left side, excuse me, to present my answer. And x is unsquared now, so square root of x squared is x, and then square root of 16 with a plus or minus will be plus or minus 4. And this is how you do regular algebra, even though you saw a quadratic equation with a quadratic term. You can do regular algebra here instead of having to do quadratic algebra, which is more factoring tricks. So I want to emphasize that. You could have possibly factored this one as well. I'm sure there's a nice little difference of squares part of this that's going to come out. So it's not that factoring isn't allowed here. It's just that you can do regular algebra here. If I go on to this next equation, let's go straight to this one right here. That 0 is equal to a quadratic trinomial, x squared minus 3x plus 2. So this is the case where I see a quadratic term, and a linear term. And then solving, I'm going to use what I call quadratic algebra. You want to set the equation equal to 0 using normal algebra. It already is. That's great. But you always want to double check for that. Okay, I see a linear term, so I'm thinking factoring here. Then the next thing I want to do is I want to do my basic factoring of looking for monomials. That's variables and integers like 2x or 3y or maybe just a 5 or something like that. You're looking for monomials that are common in each term. x squared, x, and no x. So x is not common across all three, so I can't factor out a variable. And there's a 1 in front of this one. Remember, there's an understood 1 in front of there. A negative 3 and 2, and they don't have any common factor integers there. So then I'm going into factor into binomials. So this is my next stage. So this is why you've been practicing probably 10, 20, even 50 of these factoring tricks, because you want to get to this stage where you solve and you're looking for factors 2 here that add to 3. Well, it makes it nice. 2 and 1 add to 3 with the minus, both negative. So all that practice you've been doing with factoring into binomials and such, it's to get to the point where you use the zero property. The zero property to start looking and finding solutions. This is my favorite question in mathematics. It's what makes 0, or what x value will make 0. So if you look at this and you think, okay, this binomial, these two things multiplied have to make 0. So either this binomial or this binomial is going to make 0. So you consider both options. Looks like x is going to be 2 for this one, and x is going to be 1 for this one. Both of those will make 0, and those are both valid solutions when you're trying to solve for x. Now, I always tell my students right off the bat that, you know, why we're doing this is that we're trying to find intersections on a graph. In this case, I'm looking at this parabola, which is my x squared minus 3x parabola here. Okay, x squared minus 3x plus 2. That parabola hits the y equals 0 line. That's the x-axis. Hits the y equals 0 line in 2 places. 1 and 2. 1 and 2. That is the solution to this, but it is also the intersection of 2 equations, or 2 graphs. Keep that in mind. All right, let's try another one. 2x squared minus 12x plus 32. It has a linear term. I've got to do the quadratic algebra. I'm going to kind of race through here a little faster now. Please forgive me. I'm going to set the equation equal to 0. So the first thing I'm going to do is 2x squared. 2x squared. Let me give myself just a bit more room here. So I'm going to take the 2x squared. I'm going to leave it on this side. Add over the 12x, subtract over the 32, and that does leave it equal to 0. So when I say set equal to 0, I'm talking about doing little algebra moves to get 0 on one side of the equation. Factor out any monomials is step number 2. I see a 2 across the board, not an x, but I do see a 2. So now I'm going to take out, I'm going to factor out. We used to call it divide out, but it kind of led to confusion because you're not dividing it out yet. You will in a bit. Okay, but you want to factor out. You want to factor out the 2 because that's clearly been distributed across all 3 of those terms. Whoops, not 12. What is that? 16. 16 again. That's twice I've had that one. Equals 0. Step 3, factor into binomials. So now you got a 2 out front. You got a 2 out front. Need to make myself a little more room. Apologize here. You got a 2 out front, and now you got to think, okay, how am I going to get this trinomial into 2 more factors? And that's that binomial factoring. So again, you're looking at factors of 16 that have a difference of 6. That's how I teach my students. So I always want them to do a little bit of scratch work here. A little bit of scratch work. I want them to think, okay, factors of 16. You got 1 and 16. Whoops, can't draw that. You got 2 and 8, and you're looking for a difference of 6, and you got 4 and 4. So if you look at all those factors, 2 and 8 are clearly the ones that have the difference, of 6. Now you need a positive 6x in here, so I'm going to make this x plus 8 and x minus 2. And you want to check your middle term, negative 2x, positive 8x. Yep, that works. Now my favorite question, what makes 0? Well, 2 is a constant. It's constantly 2. That's why they call it a constant. So it's never going to be 0. This factor right here will be 0 if x is 2, and this factor right here will be 0 if x is negative 8. Hopefully you're getting a feel for this one. Same idea. You see this next equation? I'm going to set it equal to 0. This time, I want to keep my x squared positive. I feel it's easier, and I want you to be flexible in moving numbers on either side of the equation. So I'm just going to subtract 10x from both sides. Quick little move there, subtract 10x. That's step one. I set it equal to 0. I'm going to factor out any monomials that I see. In this case, I see both an x term and what, a 2 that is common in both of these. I see a 2 and an x, a 2 and an x. So now I'm going to factor out, say 0 equal a 2x, and then I'm going to open up parentheses and think, what was 2x distributed to that made this 4x squared minus 10x? So this is why we always want to factor out first. So sometimes you're not even going to go to this trinomial to binomial trick. Sometimes you're going to factor out and see your solution a lot faster. Okay, so if I look at this, 2x times 2x makes a 4x squared. 2x times negative 5 is a negative 10x. That does work. What makes 0? I always tell my students, I always write this little acronym. What makes 0 here? Well, x equals 0 will make this whole thing 0. Come back to the original equation way up here. If you put x in, is that going to make it equivalent on each side? It sure will. So x equals 0 is an answer that we probably could see right off the bat. The hard one that would have been to see was this, 2x minus 5 when this is set equal to 0. Little two-step algebra. By this stage of the game, I'm hoping you can do it mentally. Yes, I said that. A teacher does not want you to necessarily write down the steps on this one. We're hoping you're so flexible that you could add 5 and divide by 2 and not think of the calculated answer. Keep it in fraction form. Just leave it 5 over 2. Yes, that's 2.5. And yeah, we just found the intersection of a line, 10x, and a parabola. And the intersection of those two guys, that happened at 0 and 2.5 on the x-coordinates. One more. Let's do one more here. So I've got a 4x squared plus 10x minus 6, first trick. Think you know what I'm going to do. I'm going to add 6. Why? Because I'm setting it equal to 0. Why? Because I saw a linear term, and I've got to do this quadratic algebra, and the first step is to set equal to 0. So that's why. I look for common terms, not an x this time, but a 2. Clearly a 2's been distributed. I get a 2x squared, 5x, and a plus 3 equals 0. Ooh, a difficult quadratic trinomial because there's a 2 in front. Now, there's some videos out there that'll show you some tricks to this one, but I always want to emphasize to the students that it's good to be flexible with numbers, comfortable with numbers. Take the 2, put it up front, up on top, and just a little setup to help you go through the options in a very fast and organized way. 2 will be multiplied to one of those guys. 2 will be multiplied to one of those guys, the one over here. So it's either going to get multiplied to the 1 or it's going to get multiplied to the 3. I'm looking for a sum of 5. If I multiply 2 times 3 and add it with 1, that's 7, not 5. If I multiply 2 times 1 and add it with 3. So the 2 times 1 goes there, and that means the 3 goes there. We're looking for a sum of 5x, so both are positive. So again, this is why you've done those little tricks. Don't forget, this is equal to 0. To get you set up so you could solve this quadratic algebra. What makes 0 is our final little step. Little two-step algebra in your head. Two-step algebra in your head. You're going to subtract 3. Okay, set it equal to 0 visually. Subtract 3, divide by 2. So just subtract 3, divide by 2. You got a negative 3 halves, and over here you've got x equal negative 1. And I want to show you that. Over on the right side here, I have this parabola equal linear. Don't forget, that's what we started with. We started with the idea that we have a parabola on the left-hand side of the equation. That's the 4x squared plus 10x. And that's what this purple big U graph is. Okay, and if you're not learning how to graph that yet, you will be soon. And y equal negative 6 is just the horizontal line. And if you look carefully, they do intersect right down there. At where? Negative 1 in the x-coordinate. Yep, negative 1 in the x-coordinate, and what, down a bunch there. and then negative 1.5 and down a little bit there as well. Down the same number as well. It's a symmetry point. And that's really important that you always remember intersections are solutions. This is a huge lesson. I hope you play it again if you have to. I'm David from Electric Teaching. Thank you for listening. I hope that I have helped.